All right. 11.4 dividing radicals. Got some timer. All right. Okay. One of the things that your book talks about is you're going to express as a fraction or as fractions. So, for example, square root of 40 divided by square root of 5. You need to rewrite that as a fraction. Y'all better take notes today because I'm going to be checking. If you don't have all my notes, I will not help. Got it? Hear me in the back? Okay, I know you do. All right, so just like we did before, are these perfect squares? No. Really? This is a 40 is a perfect square? You're just shaking your head.
Yeah, I was
okay.
just.
All right.
Yes,
no, they are not perfect squares, so we're going to go ahead and put them all under one radical sign. And 40 divided by 5 is 8.
And that's your answer?
No.
Oh, wait.
No, is that simplified, Franz?
No, it's not.
There you go. How do I simplify it?
You need a 2 times 2 times 2.
Okay, we need to do our factor tree. And we have 2 times 4, or yes, that. And I'm going to say, some of y'all are trying to do it in your heads. Not naming names. They know who they are. Guys, I know it feels like death having to write a little extra. But it could save you some time in the long run if you're having to redo some problems. So then we write down our prime factors. What is my root, Franz?
The root 2.
That's right. My root is 2. Because I don't have any number there, so we know it's 2. And so what do I group?
Just 2 2s.
2 2s. That's my leftover. Mm-hmm. So what goes on the outside and what goes on the inside?
One of the 2 go on the outside.
So 1 2 goes on the outside, not both of them. Well, because I'm making sure you get that. 1 2 goes on the outside.
And make a check mark. And then 1 2 goes, the only 2.
The leftover goes in there. And that's a radical sign, but we can call it a check mark if you want. And there's your answer. So that's your basic division if both of these can be, simplified or divided, okay? Oh, chap, what is on your mind?
If you have one that can't be...
I am not there yet.
Oh, okay.
This is an example of when it works really nice. 40 can be divided by 5, right? That's your basic division. We understand that. But...
No.
Let me show you another one. Does everyone understand this?
Yes.
All right, here we go. That's the I always start off easy. So let me do my examples and then you can ask questions. What if I have this problem? Square root of 15 divided by the square root of 12. First question you ask. Okay, hold on. Don't jump ahead. First question is, are these perfect squares?
Yeah.
No.
No, I I'm sorry.
No, they are not perfect
I'm sorry.
squares. All right, so we're going just like we did up here. We're going to rewrite it. Now, 15 cannot be divided evenly by 12. Like up here, 40 could be divided by 5. And we were done, basically. It was easy. But 15 can't be divided by 12. But, Miranda, what were you saying? That's right. So we can reduce it by 3. So you're going to simplify first. We're going to make it a lot neater. And we get...
square root of 5 over the square root of 4.
That's right. The square root of 5 over the square root of 4. Because 15 divided by 3 is 5 and 12 divided by 3 is 4. Okay, now we are done with this. But we can't leave it this way. This is not the answer.
Perfect square.
Nah, just wait. We're going to separate it now. Some of you are going to get to the point where you can go from this step to this step. Okay? I'm showing the steps in between, but some of you will be able to do that. Okay? And that's fine. All right, now, Franz, what did you say?
The 4 can be divided by 2 and 2.
That's right. This is a perfect square. So we have the square root of 5 over what, Franz? The square root of 4 is?
2.
Very good. Now, we are done. That is your answer.
You can leave it that way?
You may leave it that way. Yes, exactly. 5 is prime.
And if 5 was a perfect square, you just...
You could change that too. That's right.
And if they're both perfect squares at the very beginning, you just...
That's right. If they're both perfect squares, you can remove the radical sign. That's the only way you can remove the radical sign is whether it's a perfect square. Or if you simplify it out like this, 5 is prime. You can't simplify anything. Okay, so in fact, I'm going to say that's prime. That says prime there. So that's the 5, not the whole thing. So we can't simplify it. It's already simplified. So that's what I'm saying. It's like a puzzle. That's why I said division is kind of weird. There's so many different things going on here. So if it's a perfect square, you can take it out. If it's prime, you just leave it as is. Like here, this is the square root of 8, but we can simplify that by doing the factor tree and everything. Do y'all see that? Okay, now I'm going to give you a rule. In this, it's easy to forget this rule when you don't use it all the time. Dividing fractions, adding and subtracting fractions, all that stuff. That's rules that you use continuously, so you tend to remember those. Dividing radicals, how often do you do this? Not very often. So that's why a lot of people forget. Okay, so here we go. There's a big rule. So I got 2 stars there. You cannot, Franz, have a radical in the denominator. It's considered, y'all better be writing this, not simplified.
What does that mean?
Meaning you're not done yet. Like, for example, right here. This is not simplified. This is simplified.
We've got square root of 5 on the bottom.
Ah, but you can't have a radical in the denominator. I'm about to show you Chat? I'm not just gonna throw a rule at you. What? Hold on. So notice there was no radical there in the denominator. Do y'all see that? So then it's okay. I'm going to put no rad. I run out of space. So it's okay. But what if I had, as just a little example right here, and you will write it down. What if I had the square root of 5 over the square root of 3? No. You cannot have an answer with a radical sign in the denominator. It is wrong. What? I'm about to show you.
Nothing.
No is your answer.
Yeah.
Right.
No, that's not your answer.
No is not your answer.
You just, okay, hold on. You don't just take it out or erase it. No, there's a process. Oh my word, y'all have got to go to bed. Stop bugging me about sports all night long.
Chap, I know it was
Memes.
you. She just called you out.
Whatever, you were too.
What? I texted you one time.
Oh, that is a lie. I have my phone right here. Liar,
I said
liar.
Baylor won. That was it.
I was up, but
And then you texted me talking about, oh, what's the Astros? I was like, get on my phone.
I didn't sound like that. It was a text
That's
message.
exactly how you sound.
That is not how I sound. Anywho, stop laughing, chat. See, you're so tired, you're delirious. All right. You cannot write this down. Cannot have. Stop.
Okay, Sergeant.
Thank you. Cannot have a fraction as a radicand either. I'm about to show you. Y'all think I'd never tell y'all stuff. I tell y'all stuff all the time. I don't just leave you hanging. For example, this cannot be your answer. No.
So that's the answer.
No, that is not the answer. Oh my
Then did it
gosh.
with this Frank, Miss Rogers. Just teach you something really hard like this.
And
then be like,
That would
okay,
be good,
rule
actually.
done.
Do your work.
I should have thought
It
this out,
would
man.
have to been
Or just
believable.
taught y'all a bunch of nonsense, but
Yeah.
we wouldn't have made it
do
for
like calculus.
past the first
You should've
5
done,
minutes
like,
of some of y'all.
calculus.
Okay, so notice you cannot have a radical in the denominator. You can't have a whole fraction under the radical sign. Like, so for example, this, no, can't have that. This, can't have that. We had to take it to this point and simplify. Here, we are able to get rid of this radical sign because it's a perfect square. So these are two major rules. You cannot have this. You cannot have that. I will show you what to do if you get that. Yes, Nu? Were you about to ask that? Oh my gosh, something's happened to her. Does everyone have this? See what happens when you go to the back? I heard you requested to go to the back.
Why?
I did it.
Are you done? Okay. A little bird told me you did. Okay. If you have a radicand as a denominator, multiply everything by its equal. And I'm going to explain what that means. If you have a radicand as a denominator, You're going to multiply everything by its equal. And I'm going to show you what that means. Basically, I'm going to let you catch up. Basically, you're going to multiply top and bottom by itself. Yes. Very, very good. So write that down. If you have a radicand as a denominator and you got to get rid of it, you're going to multiply everything by its equal. Basically, you're going to multiply top and bottom by itself. Once everyone is caught up, then I will give you my examples. Sophia, I can't see you anymore, so if you need me to stop, just politely tell me to wait. Okay?
Just tell me to duck.
Miranda, if you're still writing, that's fine, but if you're not, I need you. Okay. So is everyone good? All right, see, I can't tell. All right, example. Let's say I have radical 5, or the square root of 5, over square root of 7. We cannot have no radical in denominator. Can't have that. So the first question, I'll do it in black ink so y'all can see the back. Make sure you write these notes down nice and neat. First question, bless you. Before you do anything, you ask, can they be divided evenly? Like our very first example. So, Miranda, can these be divided evenly? No. Second question. Can the fraction be simplified? That's like, is it a perfect square? So, Ariel, are there any perfect squares here? No. So the answer to number 1 is no, they can't be divided evenly. Answer number 2, can it be simplified anymore? No. So this is what we do. Y'all ready? Are you done? While he's catching up, I want to write this. You're going to multiply the top and bottom by itself. So you're multiplying both sides by the square root of 7. Y'all see what I did there? Multiply the top and the bottom by the square root of 7, by the denominator. What is the square root of 5 times square root of 7? New? Square root of 35. And the square root of 7 times square root of 7 is what, Keith? Perfect. Do we see a perfect square now?
Yes.
So then we have the square root of 35 over 7, because the square root of 49 is 7. This is your perfect square.
So then that will be your
Doesn't
answer.
you simplify though? Like,
Hold on. We no longer have a radical in the denominator. So no radical in the denominator. So we got to see, is it as simplified as it should be? So we do our factor tree over here. What two numbers give us 35?
7 5.
7 times 5. My root is 2. Do I have any pairs?
7 30.
So this is simplified. Make sure you even put your factor tree right here in your notes so that if it'll go quicker. If you've got to remember that you still have to simplify this top number if possible. So you got to work it out. Oh yeah, there's no pairs. I just have 2 prime numbers right here that are not the same. So this is already simplified. There's no radical here, and this is simplified, so this is my answer. Yes, Chap?
So for that, because like 7 can go into 35, but you can't divide it because it doesn't have like a what you call it? Like I don't know what they're called, but it's not a radicand. Is that why you can't divide them? Like actually divide them?
Well, you have to okay, so first, remember, can they be divided evenly? So even when we get to here, this is our original problem. These are your questions. Once you get here, then you just start simplifying. Okay, and 35 can't be divided by 49. And so you just start simplifying. This is always going to be a perfect square. So some of you are going to get to the point where you're going to bypass this and go straight to here because you're going to start seeing a pattern here. But for notes purposes, y'all want to write down every step. This is always going to be a perfect square. Okay? All right. So that's how we simplify. Okay. You don't need to like reduce the fraction or anything. Let's do another one. Are there any other questions? All right. How about square root of 3 divided by square root of 6? Okay, like in the very beginning of your notes, we're going to write it as a fraction first. So I do the square root of 3 over the square root of 6.
If you would just simplify, would it just be 1/2?
Hold on. We're still in the radical though. So, like in the very beginning of our notes, can 3 be divided evenly by 6? No. So I can put it like this, or I can simplify it. Either way, because this becomes 1/2. Do y'all see that?
Mm-hmm.
Can we have a fraction under the radical sign?
No, ma'am.
So I have 1 over square root of 2. Now, could we have done that right here? Well, yes. You see what I'm saying? Some of you are going to get to that point where you are able to skip some steps. But right now for notes, we're going to just do it step by step. Valeria, can I have a radical in the denominator? Are any of these, can this be divided evenly? Any of this perfect square? Okay, so I'm going to write it again right here. What do I need to do, Valeria? To get rid of that radical in the denominator. What do we do in the example right above it? So we can't have a fraction in radical sign, or in radicand, I should say. And we can't have no radical in denominator. So, Valeria, how do I get rid of this radical 2 here? Multiply what? Okay, so I'm going to multiply the top and the bottom by the square root of 2. Excellent. So, Valeria, what is the square root of 1 times square root of 2? What do you get? Square root of 2. Don't forget your radical sign. And Valeria, the square root of 2 times square root of 2 gives me? Okay, just 2. Just for notes purposes, it would be radical 4. This is a perfect square. She's correct. That would end up being a regular 2 now. And that is simplified as we can get. So, we simplified this to here. So we went from the square root of 3 divided by the square root of 6. We simplified it to here. Cannot have a radical sign in the denominator. So we multiplied the top and the bottom by itself, by the denominator. Square root of 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4. That's a perfect square. So we can go ahead and take that out. No longer do we have a radical sign in the bottom. And this is simplified as far as it can go. New.
Is it going to do the same equation like this, but if it's not like cube or
You're going to... I don't know if they're going to even have you do any of that. You would simplify it the same, but yeah, they don't have you doing any of that. Oh yeah, they do. You would still do it the exact same way. It's when you're simplifying, though, you would do it in groups of 3. But you still would solve it the same.
I don't know, but like 4 is the square root is equal to 2.
Okay, so if it's a cube, it'd have to be a perfect cube. Okay, good question. All right, any other questions on that? Let's do another example then.
Are we in the book?
Not yet. Square root of 2 divided by square root of 75. Now we need to simplify it. None of this is perfect. We can't divide it, but we can simplify this 75, can't we? All right. So, over here, I'm going to do my factor tree. Let's see. Someone haven't called on. Ariel, what 2 numbers give me 75?
5 and 15. Wait.
Is that right?
Yeah.
How about,
It is.
Yeah, it is.
don't second guess yourself. This is prime. And then we have, of course, 3 and 5. Okay, I'm going to write my prime factors out. So, Ariel, what's my root?
2.
That's right, my root is 2. So what am I circling?
5 and 5.
There's my pair. So, we're not messing with the 2. So I'm putting that on top. But on the bottom, what is it going to look like, Ariel?
It's going to look like simplified.
Okay, so what should I write?
So you should write the 5 on the outside and then the 3 on the inside.
There you go. Okay. So we simplified the 75. You all see that? And I rewrote it. Now, can we have a radical in the denominator?
No.
Do I need to get rid of the 5 too, or just the radical, the square root of 3?
Just the square root of 3.
That's right. So I'm going to rewrite it because we got some work to do. So, Ariel, how do I get rid of the square root of 3?
By multiplying the top and the bottom by 3.
That's right. To get rid of it, we're going to multiply the top and the bottom by that radical sign, that square root that whole deal right there. Just do you see that in the back, y'all? All right, so Ariel, what do I get? Square root of 2 times square root of 3.
6.
Square root of 6. This 5, we're just going to bring that over. Valeria, do you see that? We're going to bring that 5 over. What is the square root of 3 times square root of 3?
9.
Square root of 9. So this 5, because that's going to be a question, we just brought that over. Now, Ariel, what is the square root of 9?
3.
And what operation is taking place with the 5?
Multiplication.
That's right. So I have the square root of 6 over 5 times 3. Because this is a perfect square, so I can take that out. Now I have the square root of 6 over 5 times 3 is 15. 6 is already simplified because it only has 2 times 3. So there's your answer. Any questions? Miranda, you have a question? No one? All right. Page 449, examples. Franz, we're going to end up having a lot of homework, so I got to sit and wait till everyone has their books open. And I can't continue till you've got it open. And we're already running behind. Y'all got to have to start coming up here on time. $4.49. All right, number 1. Square root of 4 divided by square root of 25. Morgan.
The perfect squares. So then you just get the fraction 2 over 5. No radical signs.
No radical signs. That's a perfect square. That's a perfect square. Square root of 4 is 2. Square root of 25 is 5. That we can remove the radical signs because they are perfect squares, and that's your answer. You can, I mean, it's simplified too, by the way. Any questions? 3. Square root of 5 divided by square root of 4. Valeria, talk me through it. What do I do? Okay, so I'm going to set it up as a fraction, and I've got the square root of 4 underneath 5. Do what? So that's a perfect square. So then what's my final answer? Square root of 5 over regular old 2. That 5 is prime, so we are done. Any questions? I hope y'all are writing this down. You got it, Valeria? All right, 5. Square root of 8 divided by square root of 4. Miranda.
2.
Just regular 2? Well, can we divide?
Yeah. So that would just be 2. Oh, wait, no. Can you do the factor tree?
Well, one of the first things we do is see if they can be evenly divided.
So your answer would be 2.
Just plain old 2?
Yes.
Square root of 8 divided by square root of 4.
Square root of 2.
There you go. Now, let's say you decided to take that out of the perfect square. And you got this. Now you're going to have to do the factor tree here. That'd be 2 times 4 and then 2 times 2. So I'd have all my 2's. It's root of 2. So then now my answer is 2 times square root of 2 divided by 2. Now Miranda, y'all should be writing this down. Now look at this. Can I simplify this any further? What? New? 2 divided by 2 is,
1.
so you're basically left with that. Same answer. 2, you can divide these numbers right here. So in this case, you can divide square root of 8 by square root of 4 and you get square root of 2. But again, if you didn't go that route and you went ahead and took the 2 out of the square root of 4, factored out your 8, rewrote it, then you can continue. So you can see there's 2 different ways of doing it. Questions? All right. You have it down? 7. Square root of 10 divided by 3 times square root of 5. Let's see. Sophia, what can I do here? Do what? You're going to have to be loud. Look at the example we just did. And what do you get? So can the square root of 10 be divided by the square root of 5? So and your answer is square root of 2, right? Right? So then what do I do with this 3? It's in the denominator, yes? You don't know? Okay, so then it stays in the denominator. There's no more radical, so this is simplified as far as it can go.
So when you divide like that, it always goes on the top, or like your division thing.
Well, if I did this, would my answer be on the bottom, or would it be on top?
On top.
That'd be 2.
Okay.
It wouldn't be 1/5 or 1/2. 2 goes on the top. Same thing. 10 divided by 5 is 2. 3 stays. Any questions? 9. 3 divided by the square root of 13. Morgan, tell me how to solve this.
You're gonna have a radical in the bottom.
So how do I get rid of it?
Multiply both sides of the fraction by that radical.
Yep.
And you multiply it by square root of 13 on both sides.
And tell me what I get.
Would get you ultimately, like if you're not gonna do the whole York scenario, like I don't really want to multiply 13 times 13. So 13 and then 3 times square root of 13.
3 times square root of 13 on top, and just in case you don't know that 13 times 13 is 169. Now you know. That's a perfect square. So then it's just 13. These two cannot, the 3 and the 13 cannot be simplified. That 13 is prime. So you're done. Yes, new.
What happened if the question is negative?
Oh, you're not going to have negatives. Yes, chap.
I know this is probably not a good question, but why does the 3 on the outside.
Because they're two completely different things.
So you can't multiply them. They have to both be and have the radicals.
Right,
And same goes for division. They have to both have the radicals.
right.
Okay.
Good questions. Any more? All right, 11. I got 3 more, and then I'll set you free, but you're not going to have a lot of independent time.
How much?
Not a lot. All right. Let's see. Keith, tell me how to solve this.
You have to multiply something by square root of x.
Very good. And what do you get? Or just square root of 6 over 6. Because 6 times 6 is 36, perfect square, and it becomes just regular 6. This can't be factored or simplified any further, so you are done. Any other questions? I got 2 more. 13. I have the square root of 14 divided by a square root of 21. Chap, tell me how to work this.
You can simplify them. Oh no, you can put them in the fraction form.
Put them in fraction form.
Then you can simplify them, dividing them by 7.
So I'm going to divide by 7.
And then you get the square root of 2 over square root of 3. And then you can't have the square root on the bottom. So you multiply the bottom and the top by square root of 3. And then you get the square root of 6 on the top. And then square root of 9, which is 3 on the bottom. Then you have square root of 6 over 3.
And that's simplified.
Can't you just
Why
divide
wouldn't
them
you-
both by 3?
Do what?
Can't you just divide them both by 3?
Well, this is a perfect square.
Why wouldn't you combine them in one radical sign, like a fraction in the radical sign?
I mean, it's not a necessity. It's just an explanation. You can really just skip through that. All you have to do is know how to divide or simplify.
Okay, cool.
All right, last one. You want to do this one? Oh, go ahead.
What if you did put then like if it's like the same thing, like you have negative 6 over
There's no negatives. We're not doing that.
negatives, not in the square root of 6 over square root of 9. So you look for if they're squared first, and then
Yes.
you see if they can
Perfect square first.
Okay.
All right, so I have 3 times square root of 5 over square root of 15. You said you wanted to do it. All right, someone want to volunteer? Chat?
Okay, so you can simplify the 5 and the square root of 5 and the square root of 15, leaving the 3 on the top. Is that right?
Yeah, that'll work.
Okay.
So what he's doing is he's simplifying by 5.
Isn't that what you're supposed to do?
Yes. So that would basically cancel out, right? Because that becomes 1. 5 divided by 5 is 1, and you don't need a radical of 1. So then you're left with 3 over square root of what? Chap?
Yeah.
Now what do you do?
You can't have the radical at the bottom, so you multiply the top and the bottom by square root of 3. And then you get on top the 3 times the square root of 3 over square root of 9, which is 3.
Am I done?
No, you can cancel out, or not cancel out, but like they do cancel out the 3 and the 3.
3 divided by 3 is? So then what's your answer?
Square root of 3.
And there you are. You're doing page 449. You're doing two through 16 even. Oh, trying to be nice. I'll be nice. Y'all can all do that.
What's the
What?
what would be like the other way of doing it?
I don't know what I was thinking. I was thinking of factoring this out or simplifying this, but that doesn't even make sense. So I lost my train of thought and I was like, what? I don't know.
That's why you have a